We're going to join this morning and talk about the cloud and Hadoop, particularly with obvious view towards Microsoft Azure and HD Insight. And for my part, I'm interested in this topic because of the way it can interact with SQL Server. That's actually what I really care about in big data, is finding new and interesting ways to extend SQL Server and help my clients find a better way to deal with things like archiving and whatnot. So I've been at this a little while. I've been working in computer technology professionally since 1990, probably another quite a bit of time before that, just as a user. I grew up in Unix and all those other wonderful things. I spent some time in the jail cell of NetWare. I'm just kidding. But I've worked a lot in competing technologies, so I have a very pardon the pun, pragmatic viewpoint when it comes to technology. I've seen a lot of it come and go, so I don't worry too much about trying to keep things the same. I'm more inclined to try to embrace the new. I joined Pragmatic Works earlier this year. I've been working in SQL Server since 6. I did have a short engagement with 4.2, and thank God that's gone. I've done lots of other platforms. I've spent a couple of years on another brand of Hadoop, which is a great product. I am a complete noob when it comes to HD Insight and Azure. I am learning this as I go. So my presentations are changing too as I go. And that's just really typical for me when I work on a topic and work in an area. I tend to continue to extend it and change it as I learn more. So I'll be speaking at SQL Saturday in Orlando this coming fall, around September the 27th. Please come out and see me if you can. With that, let's get started here. This is what we're actually going to cover in this topic. We're going to talk about how to copy data to Hadoop, how to create Hive tables, work with those tables in Excel, consume those same things in SSIS by pulling in the data using Hive and SSIS. And finally, our last presentation, we had someone ask about doing link server in SQL Server and talking directly with Hive. I'll show you how to do that too. So just a little background. The handsome guy that's really tall on the right is Doug Cutting, the inventor of Hadoop. He came from Yahoo, a small team of Yahoo that invented Hadoop. He's a great guy. The ugly guy on the left there is me, and I'm holding the actual Hadoop doll that belonged to his son. A lot of you probably have seen that doll all over the internet and whatnot, and I should call it a toy or something. It almost looks, I'll tell you, my wife is a big craft person, loves to make things with her hands. It looks homemade. So those of you who are out looking for a similar Hadoop doll, I don't think you're going to find it, but it's really cute. So, what we're going to assume here is that you're here because you've read about HD Insight or you have a working HD Insight cluster. I can tell you from personal experience that the HD Insight setup process is very easy. It doesn't take a lot of time to get out there and get it working. This is kind of in contrast to physical clusters where you have to buy hardware and you have to revision it and you have to do a lot of planning and IP addresses and all that stuff. Switches, all the forethought you have to go through is really condensed down, and that's what a lot of those topics are going to be about, is how we can leverage the speed of being able to set up a Hadoop cluster in HD Insight and get it working. Some of you, I would expect, have some Hadoop knowledge. I won't go into a lot of the bare bones stuff about MapReduce and all those things, because I'm assuming that you've either read about all that stuff or you talked to someone who has, or you may have experience of your own at this point. We're going to assume also that you don't have a lot of security in the way, firewalls, networks, all that sort of thing, that you've overcome whatever limitations those impose. And finally, that you won't be using your real production cluster to experiment with. That's a big no-no with me and anybody who's had to deal with this for a while. So let's just pretend for a second that something big has just happened, and that's kind of where this whole idea came from for me, was trying to find a way. Here you have this resource in HDInsight that you can just, with a few clicks of a mouse, set up a cluster and get it working. I think I had mine working in less than an hour, and it didn't involve almost any planning or anything. So those of you who need to do something quickly, get it stood up, and then the other side of that is the teardown. You know, you don't really want this hanging around if you don't need it, right? And you pay only for what you use. So those are the traditional arguments for the cloud. The first thing is identifying some potential data sources, right? So there's a lot of free public data sources that you can just go to their website, browse the data, download it, and like that. So the very first one is data.gov, and that's the government's attempt to become more transparent, provide data sets to everyone, not just to research facilities and universities and the CSA or you know, NSA or one of those people. It's also about sharing that data with those of us who pay for it, so we can go out and do new and challenging and interesting things with it. Department of Transportation has a website as well. They even have a data challenge going on over there. OpenStreetMap is one of my favorite places to go because it is a literal working street map. Well, we'll go up there and take a look at that real quick. If you haven't seen it, it's kind of reminds me of the Google Map stuff, only better, because it's open source, and if you're a programmer, you're going to want to go out and try to make map facilities like this. And to me, a lot of that could be very useful if you're, you know, obviously in the middle of a you know, catastrophe of some kind. So there's all kinds of APIs and things with OpenStreetMap. It looks like they have some downloadable data sets as well, so you can download all of this data. And I'm not a map expert, so those of you that are, God bless you, but that's not my bailiwick. But as you can see, it normally would load faster, but we've got Citrix running, and that's kind of slowing it down a little bit. Anyway, back to our presentation. A bunch in the scientific community, a bunch in Amazon. One of the interesting ones I found in Amazon was Enron's email data. Apparently, you can just go in there and peruse that at your will. Personally, I don't think that, you know, reading some of Skilling's email is all that interesting. So, but you know, the whole Enron debacle. So onwards. So my original premise was to show how emergency responders can leverage Hadoop and SQL Server. You know, being able to move quickly in a disaster and get data sets up and working for people using public data sets. The reality is, all the data sets that I would be interested in trying to demo are kind of obviously private because it's going to involve personal data from lots of people and who that not necessarily want to be part of my presentation. I don't know why. So what I've had to do is create a small data set based on AdventureWorks and even change it a little bit. I think everybody's now from my wife's hometown of Wichita, Kansas. So step one was to locate the data sets. Step two is to do a sort of an assessment on what you're going to do with this data, right? One thing you're going to find out really quickly, if you haven't already, is that Hadoop is really short on design tools. As an industry, the data folks like me have long been proponents of tools to help do this kind of work. And one thing, just not a lot of great stuff out there to demo this stuff outside of napkins and storyboards and whatnot. So one thing I recommend is that you look into using Excel to do a traditional mapping document, if you're familiar with those. You know, basically we're going to identify the data sources, then we're going to come in here and create an Excel spreadsheet It'll show the files, the locations, and the content that these things contain. That can be done pretty quickly. The other thing I do occasionally is use Visio for flows, where I can just go open it up and go and even the basic flow chart. Say, well, I'm getting this file from here, and it's going to go here, and it's going to be transformed in this way. You can use Embarcadero, Visio, other things like that in the traditional data modeling sense. But the problem you're going to get into is it's going to be more specifically for the use of things like Hive that have sort of a RDBMS feel to it. And it's not going to be something you can forward engineer. Like, you know, Embarcadero, I could go out and design a complete database and the structures and the foreign key constraints and all that stuff, and then say, now I want you to go deploy this over here, and it'll go do it. And as I make changes to the model, it'll automatically deploy those to the database. You're not going to find that here. We don't have that yet. So one little word of caution. One of the things that we really suffer from in Hadoop land is backups suck. We just don't have the technology there. We have a lot of the backup vendors are trying to get their arms around it and come up with products. There's a lot of noise around this, but the reality is there really isn't a good backup solution, I don't think, yet. There are recently snapshot capabilities added by some of the vendors, including, I believe, Azure has this as well. And it's becoming part of the standard, which is going to help a lot. Because imagine, you know, you've got 40 terabyte cluster, and you go make some big change to some of the data. There's no getting it back, you know, unless you've got a backup of some kind. A lot of people like to use DistCP. There's a built-in utility, and it's also available in Azure, or you can DistCP the data over to another cluster to kind of preserve it, and then go make your changes, and if something goes badly, you can DistCP it back. So when you're talking about terabytes and terabytes of data, that's really an important concept. But also, you know, on smaller data sets, maybe one of the strategies you could use is simply copy the critical data to another location in HDFS. Done that a few times myself, so that's a strategy to kind of protect things. So there's a lot of learning about Hadoop. We're not going to go very deeply into this. This guy just wants it all in Excel, and I can see why. Well, there's so much information out there. A lot of it's very good. Some of it not so much, but at least, you know, there's plenty of places to learn a lot about it. We kind of went through the Doug Cutting piece of it. It originally was based on Google's Big Table white paper. When Doug and the team were working on this over at Yahoo, you know, they were reading about this white paper that Google had released, and this is the foundation of Yahoo, of Hadoop. Now, I've seen quite a few pictures and talked to quite a few folks who've worked at Yahoo and had an opportunity to hear about, you know, the interns wandering all the aisles of all the servers. I think the biggest cluster I've heard about so far lately is around 12,000 nodes. And those are individual servers in a rack, right? 12,000 of them working together as a single unit. So, you know, their job is to wander through the aisleways and look for red lights and pull out servers and install new ones to replace them. Because of the shared nothing architecture in Hadoop, meaning that you can lose an entire server, plug in another one, and, you know, away you go. That means the chance for data loss is really small. There's 3 times replication. There's all kinds of other areas around there we can talk about. But so MapReduce is the key technology under the hood that started all this. It's changing, and MapReduce is neither a good thing or a bad thing. It is just an is sort of thing. There's still a lot of need for MapReduce, and probably will be for a long time to come. The cool thing about this is, as far as HDInsight, is that I think you could do it in Linux if you had to, but I don't think it would be easy. But at least in an HDInsight, you could go to C#, for example, and do your MapReduce programming in there instead of with Java. And that's really important for our Microsoft community. I know that most of us, me particularly, I don't really have any Java chops. I could. It's another curly brace language. It's not that different from what I'm used to. But there are people that are really good at it. That's all they do. That's all they care about. Kudos to them. So the Hadoop environment that most of you will learn about or have learned about is it's a collection of different open source projects, all being sort of under the Apache umbrella. If you go to apache.org, you're going to find all the different open source projects they support. Hadoop was released to this organization many years ago. So Hadoop is really a collection of different open source projects, not just Hadoop. And so, for example, Hive is up there, Scoop, which is a way to pull data in and out. Things like SQL Server is one of the ways we could do it. HBase, completely different sort of idea, more like a column store index sort of a situation. Pig is the lingua franca of big data. It is, if I was going to find an equivalent to SSIS in this world, Pig would be it. As far as being able to transform data in big ways. Flume is a way to automate the movement of files into Hadoop. Cool stuff. Zookeeper is a resource manager. And even in HD Insight, we have Zookeeper instances out there. I can go on and I won't. But just know that this picture is complicated, and it's complicated because different people have come up with different ideas around how to make Hadoop work for different reasons, and have different products that, or projects you can bolt on to make it do something it didn't originally do. So in Azure, it's a slightly different drummer in that it's running on Windows 2012 R2 Server instead of a Linux distro. It's currently running 2.2 version of Hadoop. That's pretty good. Works with Active Directory. That's a big security hole for most people. It's getting better, but most of us that live and breathe and die by Active Directory security, you get used to that, and you go to some environment where it's not available. It can be really a daunting thing. It can be done with PAM and other things in Linux. You can talk to Active Directory and do authentication and all that. But it just requires a little bit of setup and a little bit of thought. But this isn't the wholesale kind of file system-based security you're used to. It's POSIX, and that's a very different beast. So that's another problem area for most people. But this kind of makes some of that go away because it's all Windows-based, right? So if you're a Windows shop, this is a great thing. For me, SQL Server and Hadoop are a natural fit. One of the problems with SQL Server is it doesn't scale when you get to a certain size very easily. You start talking 10, 20 terabyte database things. You're talking about usually some kind of federation. You're talking about tying 2, 3, 4, 10 database servers together as a unit, and then trying to cluster that. Now you're talking 20, and it gets really complicated quickly when you're trying to get to some scale. Scale will do it, but it's not for the weak-hearted. This is a nice way to be able to archive data, for example. It's a nice way to have one more way to leverage SQL Server, and I personally am, as you can tell, probably fond of it. Another thing is we can quickly prototype, and that's kind of what this whole thing is about that we're talking about today, is how can we get this up quickly. I will not drag you through how to set up your own cluster in Azure. I don't think I need to because it's all wizard based. You click a couple things and there you go. But we'll go on from here. So copying data to Hadoop is actually pretty trivial, especially in a Windows to Windows world. As most of you know, we can do copy and paste between things. I like that picture. We can drag and drop an RDP. We could use the Azure Storage Explorer, which I do have installed, and I can kind of give you a quick view of that. And a lot of people are using PowerShell for the daily management of HD Insight. So that's something I'm starting to learn. It's not in my current tool set, but I'm continuing to work on it. I've worked at it's odd because I've worked in PowerShell for a lot of years, especially with a Unix background, but it's not something having done a lot of shell scripting, I was like kind of curious when everybody jumped out and said, yeah, we can do scripts, yay. So another way to do this, make this easier for you, you can stand up a shared SAN volume potentially and be able to get at it that way. This kind of starts to get into this whole thing of having the on-site versus Azure-based solution and how they can share across the VPN and all that. So that can be kind of a little bit of a complicated topic, but just know you could do it. And that's often how we do it in Linux. In a Linux Windows world is create a CIFS file share that both can see, and then it becomes easy and it becomes trivial. You want to import new data, you can throw it onto the shared volume and then go in and pull it into Hadoop. So I kind of like this cartoon. It's an early prototype, all the sticky notes. So there's a Hadoop command shell in Azure that's kind of like what we're used to in the Linux world. And it has some of the same tools, and we're going to go through that here in a second. One thing you're going to find out if you're used to the Linux side of this is that it doesn't quite work the same way. It sort of works the same way. So you're going to find that paths are not quite there for a lot of things, whereas generally speaking, it's pretty much set up and working on the other side. But I think for the most part we can get around any of the problems. It looks like all the tools for the most part are there, so I think that's pretty cool. Just went through that. So the FS commands, and that stands for file system, right? So Hadoop FS commands are used to copy and place data and delete files, all that. Because in the end, what is HDFS? It's a Hadoop file system. It's just a file system. So the common ones are to put, get, list, and ls. This one here. Most of us that work in Linux a lot, ls is our list command, like dir is our directory command in DOS or the Windows command set. So there's a whole list of these things out here. If we go out there real quick, you can see. You drop the monitor for a second, kind of get you some ideas here. Let's go leave OpenStreetMap. So if we come out to the good old Apache website where Hadoop, most of the documentation lives out here, you can see like the Hadoop FS command is here. Here's distcp that we just talked about earlier about backing up everything. Here's fsck to do a file system check. There's class path settings, there's pipes and queues, there's all kinds of things in there, but let's go to the FS one real quick. And you can start to see a list of the file system, shell system guide, cat, you can concatenate things and change groups, chmod, chown, all these are standard Unix things that you probably may or may not be familiar with. You'll see some older commands like move from local, move to local. We don't use those very often anymore. They may be deprecated, but get and put are the two main commands to move files in and out of Hadoop HDFS. So remove is here, if you're familiar with how to remove a file. There's one version of it that is recursive, so you can go down an entire tree. We'll kind of move on from here, but I wanted you to see that shell system guide because that's really kind of important. Start over here from current. So some important things to know about it. We're going to work mostly in Hive here today. It's schema on read versus schema on write. And what that really means is, you know, you're going to be responsible in some ways on internal tables versus external tables. There's two ways to create a table in Hive. You can say create table, blah, 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 and it'll go create it, but it also handles the storage for you. And it puts it in a standard user folder that your user account has got set up around it and all that. So when you drop the table, it goes and does the cleanup and drops the tables and the data that's out there. Because one thing to know about Hive is these two things are separated, right? We separate the data and the definition. Also know that there's partitioning, which we'll talk about. So schema on write, that's what we're used to, right? For SQL Server and Oracle, all the other RDBMS products. First we go and define what we're going to do. We create the database, create the table, then we go and insert data into that. Then on that insert, you know, we're actually checking it against the definition, and that's how that happens. And you get an error if you didn't do it right. On schema on read, it's kind of different. We have these two things separated in Hadoop. So you can copy data all day long out to HDFS and never have to tell anybody what the definition is until you're ready. And I think that's kind of powerful. And that goes back to the public data sets. Like, you know, a lot of them you may not need right away. So you could actually stage this up and, you know, kind of create these data sets out there, especially if you've got any size on a cluster. Allows you to add these files easily and add more knowledge to a table and not have to do a lot of work to get it. So it makes it very fast. One thing to know about Hive is it's tough. It's really tough. And it will do anything and everything to get something to work. It'll do illogical, silly, wrong things. You can define like the delimiter and the KID table definition, and you could say it was a pipe delimiter and it's really CSV, and so you'll get, and the result set is a bunch of scrambled data that doesn't even look like anything that you should even have in a table anywhere. So know that you know, Hive will not protect you from yourself. You can do some really interesting weird things. So one of the things I like to do, you know, a lot of times what people want is, well, gee, I'd like to take some data out of SQL Server, and then, you know, how could I do that quickly and easily? Well, I built a little table generator that just follows the basics tenets of Hive, that you just go into a SQL Server database, and you could even get it to iterate off of, you know, having call a store procedure to have it generate off of this. So you can basically script out the tables as if they were Hive tables, and that's really going to be important later, because then you're going to be able to use those in Hive. The DDL for Hive looks like pretty much like anything else, except here's this external keyword that's saying I'm managing it, not Hive itself. I'll let you explore that on your own. I don't want to keep going slowly here. So the Hive DDL, let's take a second. Let's look at this little script I wrote. So first off, to see that we have to create a database, right? So we do that in Hive like this. I like to, you don't have to use this, but I like to use the if not exists everywhere, because it, you know, basically it's going to go test, just like we can do in SQL Server. Hey, does this thing exist? If not, go ahead and make it. And one of the powerful things, this is more like Oracle, and that you can comment anything in Hive. And I love that, because that becomes self-documenting. So if this is not a temporary data set and you keep it around any length of time, people can understand what does this column do, and not have to get out, you know, some kind of a design document to see what it is. And so you can actually go through and tell people what this is supposed to do. And you can do it at the database level, you can do it at the table level, you can do it at the column level. So here are the different columns. Now I've only picked string as a data type, but you know, they do support int and big int and all kinds of things. I don't think there's a unique identifier. For those, you can go to the documentation. I just did it to make it easy on myself. So Here's the actual table comment right here. Here's the partitioning statement, and this is one of the really powerful features, in my opinion, is the fact that you can go ahead and partition by some key, and often with me it's the load date. That's what I really want to know about, is when was this data loaded, but not necessarily for everybody, but you could do it this way. Here's where the row format gets told to it. What are we going to use? Well, I'm going to use a comma. I could have easily used a pipe symbol or anything else. In fact, I think I've had to use octal occasionally with some data, and there's a way to do that with a backslash and the three numbers and so forth to tell it that that's the terminator. And then typically we also have to tell it the location. Well, the location, the way I have it written out, is the way we do it normally in Hive. In a Linux cluster, we just give it the physical. We could have also used there's an HTTP reference that we could have done here too, instead of the actual physical location. Later on down here, you'll see that we've got the altered table, and I'm adding a partition to the table. And here I'm using the WASB location, where it is in HDInsight, how to navigate to exactly this table, and even the partition that I've set up. So let's take a trip over here with RDP and go to the Hadoop command line up here. Now when you set up Azure, before we go in here, let's go back into, I'm always in the wrong place around here. Let's see. Okay, so this is a portal you're probably familiar with. As you see, we just have the one HDInsight cluster running right now. When you click on this Manage Cluster button, what you'll get is this simple little Hive editor, the job history. I don't know why that's bothering me. File browser. Let me move this out of my way for a second. That type of thing. And you can see in here we have a folder that it can see. We can drive down in here and look around at some of the stuff. Let's look in the dev directory, test.tv. So we're actually inside the sort of HDFS of this stuff. Residence table here. Here's the folder. Here's the actual CSV file. Hadoop itself uses a lot of compression, and we're going to get into talking about that. A lot of times when you click inside these on a lot of clusters, what you'll see is the actual part files that these consist of. In this one, it's not doing it that way, and I'm not quite sure why, but it looks like I could open or save the file. Let's just open it for fun. And it sees it's CSV, so it's going to bring up Excel. As I mentioned, I've changed everybody's addresses to Wichita, my wife's hometown. All right, so that's the file browser part. What else is in here? I guess that's everything. You could literally write some kind of little query in here. I think the little Hive sample table is actually done by Microsoft for us. I just submitted the job, so you see it's running down here below. Okay, anyway, let's go back over here. Let's click on this Hadoop command line button. I swear I did connect. I did open. We'll just do it that way. Didn't like that. So what you got is pretty unimpressive, right? We're at a command line. So this is how I'm going to talk to Hadoop and say, what have you got out there? I can't find it. Interesting. Can I do this? I can. So these are all of the commands that I could be doing. As I mentioned earlier, append to file, cat, checksum, change group, change chmod, chown. I'll switch over to the way we talk about it in Linux. Count. These are all the things I could be doing. Get, is there right here. Put is right here. So let's see if we can, yep, there we go. So I use the list command to show me the root directory, which in our Linux world is backwards, from on the backslash stuff that we use in DOS-ish sort of commands. So there we go. We have the dev directory, dev1, or 2 that I created, and you'll see over here on the left what the rights are in POSIX, who created it, who the group ownership would be, all that. So that's actually Hadoop. So now at this point, I'd like to show you Hive from the command line. So we're going to go. Let's see if this works. Let's see. I don't think this would work. Let's try Hive home. Yep. Oh, probably not in the bind directory. Let's see where we are. Yep. There we go. I didn't say I was perfect, people. All right. So once we're in the Hive command line like this, we can do show databases, right? It's more kind of like you might see with my SQL in that show commands, and I think that also, if I remember right from the command line, then Oracle works the same. Notice I need a comma delimiter or a semicolon to delimit the statement. So here we have a default database being shown and testDB. So one of the things we can also do is describe testDB. I think I'm missing a keyword. Got to spell that right too. So you'll see there's the comments coming back, and there's even a describe extended that you can do. Which will also typically it'll give you more information. Let's use testDB. Show tables. There's a table called residents. Describe. So remember all those comments that I mentioned that you could be doing? Well, there they are, and that's how you do them in script. So when you have a whole bunch of people on a team, or even for yourself, it's nice to be able to not have to go to some other place to look for the documentation. So let's try something real quick. Watching the time a little bit. I'm going to cheat. Let's see. I'm not going to cheat that way. I have to go over here. Let's go get this demo data here. Copy. Okay. I think I could just paste it, right? So that's one way to get the data, the table, the text file out there quickly, right? We can do that. So let's exit Hive for a minute. It sort of works like I could do in Hadoop on that. Does that work? Yeah, good. Let's put this someplace where I can find it. And I think I did this the other day, so we may not have to do much of this. That's the file location itself. Here's demo. Okay, yep, it's right here. So there's the CSV file. So let's get this in the buffer real quick. We'll cheat again. Let's get the name, an ugly name. Hadoop FS put paste that ugly name, dev1. I'm just going to put it at dev1 for the moment because we're a little bit worried about the time. So now you can now see the file's been moved up there, right? All right. So actually putting data onto Hadoop is actually trivial, right? Especially for the Windows folks, because you're not having to go get a third-party tool or use something like SCP, or you could technically use an SCP, I suppose. But in any event, so that's kind of the server level. How do I get something up there? Up here, I have as well the table definition up here. And you'll notice how these files are named HQL. That's for Hive SQL. So let's just open this with Notepad. Here's the create database statement we got from earlier and all that, and how to create the table. So basically we just run that, copy and paste this inside of Hive, or we can actually open it from the command line with a -f, I think, and open the file that way. So that's how we would create it from the command line. So now let's go out of this. Let's run over to Excel real quick. I have to say I really like the Windows 8 interface. Not everybody does, but I'm one of the weird ones. I like it. So we're going to get it from other sources, right? Most everybody knows how to do this except guys who really work with other data. Let's go back to our presentation real quick. One thing that you'll notice when working with Hive is it's sometimes slow. Oh, darn, I wish I'd done that. Okay, we were about here. Yeah, here we go. So we have MapReduce going on under the hood. MapReduce is really a powerful thing, but it takes a while to spin up. And that's kind of what the freight train illustrates. You know, freight trains are really powerful, but it takes them a while to get those big gears turning. Where MapReduce really comes into effect is when you start filtering data. If you just set select star from testdb.residence, it's going to come back very quickly because there's no MapReduce involved. When we do it with a filter, it's very slow. This is kind of a basic screenshot of what MapReduce is and how that works. You've probably seen this before, so I won't take up any more time on this, but that's where a lot of the time is spent. Non-MapReduce solutions like Impala, and Spark, and so many of the others, a whole bunch of these things coming onto the scene, where MapReduce isn't the way that the data is gone after. They have ways to get it besides that. So know that you know, Hive is one answer. It's a simple answer. It's a reliable answer, but there's a lot of other answers coming, and a lot of them are already here. Compression in Hadoop is really, really important. Here, I haven't quite explored it enough to find everything. I do see it supports Snappy, like it does in Linux, probably the very best of compression codecs. gzip is supported, and then gzip isn't all that useful because it can't do splittable containers and whatnot, which I won't go into, but just know that probably where you can change the codec, probably looking for Snappy. bzip's not included. The most interesting paper on this at all is from Microsoft themselves on Hadoop and compression. I recommend this even to my Linux folks. It goes through every last piece of why compression works and why it's important and how to use it. So To get started with the Excel demo, you're going to need to download the ODBC drivers for Hive. Be sure to get both 32 and 64-bit versions. Not everything knows about 64-bit. Like I believe SSIS is limited to 32-bit. Could be wrong on that. I'm not an expert in that area, but I believe that's right. And then there's a configuration step for these. So the steps are, we go out to the ODBC administrator. You can search that over here in Windows 8. Go through here and select the 32-bit driver. It'll show you the 64-bit DSNs, but you can't do anything with them. Put in your data source name, your host, pretty much everything else, like TestDB I created earlier. But then leave the Hive server 2 alone. There's a 1 and a 2. That's the one you want. Mechanism is defaulting to Windows Azure HD Insight Service. Leave that alone. Most of the time when this is set up in Azure, it seems to set up the admin username. Just go ahead and accept that and give it a password when you did that. And that's what you're going to do here, and then do a test and it should work. A couple of the other changes you need to make is, like, I think the original rows fetch per block was around 10,000, which was way high, I felt. The other key one that's really important is this default column string length is set to something like 34,000 or something ridiculous. So every time you try to work with like SSIS, it's going to see that as an in-text type that's not supported by the driver. So the last thing you want to do is use that. Change this to something reasonable. I think I've done it up to 4,000, 2,000s. I think I left this line when I did the snapshot of this. Everything else is fine. So once you get there, we've been through that part. Let's go here. So now I'm looking at the Hive DSN here, right? And it's going to pull up this. So I'm going to have to go grab something real quick. Love for Emily Dickinson. How about that? You're not going to see that everywhere, huh? Okay. So let's test the driver to make sure it connects, which is part of the ODBC query part. I didn't like that. Must not have copied it right. Nope. Don't know what I just did to Emily. Look at that, it connected. We're going to say OK to that, and then it's going to chug for a minute. It doesn't give you a lot of visual warnings about what's going on. So here's our residence table, right? Let's just get all the columns. Next, next, finish. And it's going to chug along and go and get that data from Hive all the way out to Windows Azure, bring it down for us. Where do we want to put it? Sure we do. I didn't say it was fast. It takes a while to get that locomotive running. Bingo. Ta-da! How about that? All right, so we're going to kind of speed this along. We're kind of running out of time, so let's go back over here. A lot of you probably want to see the little demo I did for setting this up in a with a linked server. because of the way I named this, it's going to look a little silly. It can't read that, so it's going to have to just trust me, I think. I can't go read the definitions, what I'm trying to say. Oh. Select. I must have done something wrong here. Let's find out, shall we? Quit. I hate that. I don't know what the deal is. Let's see. Bingo. There you go. There's the data back. Everybody from Wichita. Awesome. All right. Probably got a few more minutes to go through a little bit more. I'm going to go ahead and gamble on that. Let me go out here to SQL Server Data Tools. Having to move this little window around. Recent. Let's just get this one. Okay. Here we have a standard SSIS package, really unremarkably named. We also have the sample DSN down here. In the data flow, we're just going to go from, basically we're going to go straight from Hive into a destination on my local PC here. I think it's in the Xenon table over here. One of these guys, like test. So let's just, we can close this now. All right, so let's just run this real quick. So the important thing to know out of this is that once you get your data, so we went through the steps, right? We found a data source that we were interested in trying to load for that purpose, put it in Hadoop, described it, thought about, did this kind of analysis phase on what is the data and why do we care kind of a thing. Then we went ahead and figured out how to load it in Hadoop and then consume it in a variety of ways. All of that can be done in a matter of a couple of hours, and of course it worked because I tried it earlier. Well, I shouldn't say that. You know how that works. So basically, the power behind this is being able to quickly stand up a very complicated, very sophisticated Hadoop environment, and do it quickly with just a couple of clicks of a button. I find that to be remarkable. In the other context, it's a lot more work. All right, so let's try and finish up here. So I went through that, got you through there, the link server. Storage Explorer is another way to do this stuff. You can actually upload files to Hadoop this way. This is out in Codeplex, and the link is in the back of this presentation. It's not bad. It is kind of interesting. It looks like it could be extended some. I like it. I think it's another neat way to drive around, look at the data out there. Here's some additional resources as well. Microsoft Azure's, as you know, is well documented, and there's quite a bit of information, people doing demos like I'm doing today. But the Azure site itself has really been helpful to me. Another thing to look at is Microsoft's Power Query add-in for Excel. It'll let you do some of the same things that you could do for the Explorer tool I just showed you. I don't know, I clicked on it, unfortunately. All right, let's go back in here. If you want to read more about this topic, I would really urge you to get the Hive book and the Hadoop book. Really, under the hood, that's what you're working with, at least for now, at least in this context. All right, that's pretty much it. I'm done. Are you guys got any questions?
Yeah, we have a couple. You ready?
Yep, go ahead.
Okay. Shared SAN volume, can you use CSV storage spaces?
Right.
They want to know, can you use CSV storage spaces?
That I don't know. I don't know enough about that area. Let me just take a note, or at least would you forward that on to me after the presentation?
Mm-hmm.
I can do some checking on that. That's something I'm not aware of. Okay.
Okay, and then the next one is, can you use it as an ODBC dest?
Destination?
No.
To actually send files back to Hadoop?
I'm guessing, yeah.
Yeah. You know, I don't think so. I don't think there's an ODBC layer on the other side to receive it. There's no way to update anything in Hive. Hadoop is a write once sort of file system. There's some, it gets to be a really deep topic quickly, but just know that, you know, basically what you put in place is what's going to stay there. So it doesn't have that kind of writability that they might be thinking of in an RDBMS world. So my answer is no.